Okay, so in the previous video I talked about how cumbersome the calculation of the correlation could be. In this video I wanted to show how we can do it on the calculator, which is the way in AP Statistics we really will be dealing with this. The first thing you're going to need to do with your calculator, if you haven't done correlation before, is you're going to go second and then 0 and get into the catalog. The catalog is an alphabetized list of every single thing your calculator does. And it's actually automatically an alpha lock. You can see the little A up there on mine. So you can just pick the letter you want to go to. I want to go to the D's. Okay. Now, I'm going to scroll down to diagnostic on. Now, you will not need to do this step again as long as you don't change your batteries or reset the memory. Once you've turned the diagnostic on, your calculator is now ready to calculate the correlation for you. Okay, I'm going to go in here. I've got stat, edit. I still have the data from the previous video about the aunts and uncles and cousins. And if you remember, the graph was pretty linear. It looked very linear. It looked like it was going to be a strong, positive association there. So now we're going to calculate the correlation. I would guess it would be near 1. Of course, 1 would be perfectly linear, but I think this will be pretty strong. You're going to go stat, calc. Scroll down, you see number 4 is linear regression, ax plus b. I'm not going to use that one. I'm going to use number 8, a plus bx. There's nothing different about the two other than which letter is the y-intercept and which is the slope. But your book typically uses the a plus bx, so I'll stay consistent with that. Choose it. I'm going to set, well, that all looks correct. List 1, list 2. So I'm going to hit calculate. And there it is. So up here you have the equation of the line, and down here R is the correlation. So the correlation is 0.889. So as we said, very strong, very close to 1. So this is, as I said, the way we'll be typically looking at correlation in AP Statistics. So I just want to remind you, and we've talked about it before with the ridiculous shoe size and reading example, just because a graph looks good or just because the correlation is high, that does not imply causation. And there actually is a website kind of dedicated to finding these ridiculous examples, and I have a couple here, like divorce rate in Maine and consumption of margarine in the United States. Those things are very correlated, but obviously they have nothing to do with each other. Number of people who died by becoming tangled in their bed sheets and the revenue generated by ski facilities. Again, obviously, they follow very closely together. They have nothing to do with one another. So it's just kind of a funny example and a reminder that just because two things graph out to be extremely linear, that doesn't mean that the explanatory causes the response. So to wrap this up, what does correlation measure? Well, correlation measures the strength of linear relationships. Okay. The closer to 1 or negative 1, the more linear the data is. As we saw on the website in the previous video, correlation is definitely not resistant to outliers. Correlation will always fall between -1 and +1. Correlation does not have a unit of measure. It's simply a number that tells us how linear data is. There's no units to it. Correlation does not imply causation. We just got done talking about that. If you were to switch the explanatory and response variables, meaning for our example in the first part of the video, if I switched aunts and uncles, number of aunts and uncles to be the response and number of cousins to be explanatory, what would happen to the correlation? Nothing. Correlation would not change at all. Okay, because it's simply a calculation that it really doesn't matter which one x and y is. And it doesn't matter, what the explanatory response is, because it doesn't tell us anything about causation. It simply tells us, if I graphed it, would it appear linear? What would happen if units were changed? So if I had done a data collection on height and shoe size or something like that, and I decided I wanted to go from centimeters to inches, what would happen if I changed all my units? Nothing. Okay, that would not change how linear or nonlinear the data is. So just a couple last things to think about with correlation.